So I'm on to the second chapter, and the second chapter is known as the second derivative. How is that going there, the second derivative? Not the best. So the second derivative is if s was equal to 6t cubed minus 2t squared plus 5. The SDT, to differentiate it, is the 3 sixths are 18t squared minus 4t. That is the first derivative. But if I differentiate again, it's known as d2s dt squared. And that's the second derivative. 2 18s, 36t minus 4. If y was equal to 2x minus 5 to be cubed, dy dx is known as its first derivative. How would I get the first derivative? It's a chain rule. We said u is equal to 2x minus 5, making y equal to u to be cubed. Du dx is equal to 2, and dy du is equal to 3u squared. That makes dy dx equal to dy du by du dx. Dy du 3u squared by 2, which is 6 times u to be squared, 2x minus 5 to be squared. That is its first derivative. If I wanted second derivative, I differentiate that. Yes? To differentiate that, what would that be? A chain rule. What would I let u equal to? 2x minus 5. And what would that make y equal to? 6u squared. Du dx would be 2. And dy du is equal to 12u. And in this case now it's d2y dx squared is equal to dy dx by dy du by du dx. Dy du 12u times 2, which is 24 times u 2x minus 5 to the power of 1. So how do you get the second derivative? You differentiate twice. Now, if y is equal to a function in x, yes? Or if y is equal to, if s is equal to a function in t, that's going back to you, physicists, that displacement is in terms of t. The SDT is the rate of change of distance with time. And the rate of change of distance with time is speed or velocity. Now, d2s dt squared is equal to the rate of change of speed. And what do you know that the rate of change of speed is? Acceleration. So, if its speed is a function of time, when you differentiated one, you have a formula for the velocity. And does the velocity of an object change as time goes on? Well, it definitely does if you throw it upwards. So what's going to happen velocity as it goes up? It will slow down. And when it turns around, what will happen on the return journey? When you get the 2s dt squared, you now have the rate of change of speed. And the rate of change of speed, that is known as your acceleration. So the SDT is a formula for speed. The second derivative is a formula for acceleration. Now I don't have to get into that yet today. Yes? My job today is to show you how to get d2y dx squared. In other words, you differentiate that. Okay. And when you're asked to do that, sometimes they ask you to solve differential equations. Yes? So I will show you a differentiation equation. It says y is equal to x times e to the minus 2x. And then you are asked to show that the 2y dx squared plus 4 times dy dx plus 4 times y is 0. And to solve that equation, you know what y is, yes? The y is x times e to the minus 2x. You don't know dy dx, and you don't know the 2y dx squared. So you must calculate both of them and sub it in. So if y is equal to x times e to the minus 2x, what kind of a rule is that of differentiation? That's a product rule. Why is that a product rule? It's a function of x by a second function of x. U is equal to x, and b is equal to e to the minus 2x. du dx is equal to differentiate x, and dv dx is equal to, well, what is this? This is a change. So you get minus twice e to the minus 2x when you use your chain rule. And then dy dx is equal to u dv dx plus v du dx, which is equal to u x by dv dx minus twice e to the minus 2x plus v times e to the minus 2x by 1. I have choices. I can take e to the minus 2x outside, and what will I be left with? Minus 2x plus 1. Yeah. So that's dy dx. Now, how would I go about getting the 2y dx squared? I differentiate that. And how will I differentiate that? That's a product rule. And for the product rule, I let u equal to e to the minus 2x, and I let v equal to minus 2x plus 1. Du dx is e to the minus 2x. What is that? That's a change. What will it give me? Minus 2e to the minus 2x. And dv dx is equal to minus 2x, and the 1 is 0. And then the 2y dx squared is equal to u dv dx plus v du dx, which is equal to u e to the minus 2x by dv dx, 2, plus v minus 2x plus 1 times du dx minus twice e to the minus 2x, which is equal to twice e to the minus 2x. That will give me plus 4x e to the minus 2x. And once that, minus twice e to the minus 2x. They're gone. So it leaves me with 4x e to the minus 2. Yeah. So now your differential equation said to prove that the 2y dx squared plus 4 times dy dx plus 4 times y turned out to be 0. The 2y dx squared, 4x times e to the minus 2x plus 4 times dy dx, I have to go for that one, minus twice x e to the minus 2x plus e to the minus 2x plus 4 times y, x times e to the minus 2x. I have to show that that all turns out to give me 0. So what have I got here? 4x e to the minus 2x minus 8x e to the minus 2x plus 4 times e to the minus 2x plus 4x times e to the minus 2. And does that give me 0? No. Alright. Have I left out something? Oh my God. Where did I make a mistake? Here?
Where dvdx is minus 2.
dvdx is minus 4x minus 4 e to the minus 2 minus 4 e to the minus 2x plus that minus 4 e to the minus 2x plus that. How are we going now? Which is equal to, so therefore it is. And that is known as a differential equation. Right? So to solve that differential equation, I have to work out dy dx and then get d2y dx. I need to teach you nothing new about differentiation. But once you've found dy dx, how do you get d2y dx for it? Differentiate it. Yeah. There's no new different, like it's a chain rule or a product rule or a quotient rule. That's all it will be. It will be one more of them rules yet again. All right?